Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Aurelita Elsa Regina Arianto and I'm from Management. Today I'm gonna answer the assignment of linear programming. Manufacturer produced two models of racing bike, B and C, each of which must be processed through two machine shops. Machine shops 1 is available for 120 hours per month and machine shop 2 for 180 hours per month. The manufacturer of each bike of type B takes 6 hours in shop 1 and 3 hours in shop 2. The corresponding times for C are 4 and 10 hours, respectively. If the profit is $180 and $220 per bike of type B and C, respectively, how should the manufacturer arrange production to maximize total profit? To answer this, first we need to consider bike B as X and bike C as Y. And we have the constraint is X greater than or equals to 0 and Y is greater than or equals to 0. On shop 1, manufacturer of bike B are 6 hour and bike C are 4 hour and the maximum hour are 120. In this case, the constraint is 6x plus 4y less than or equal to 120. If x is 0, then 4y is equal to 120 or y is equals to 30. And the same thing goes with y. If y is 0, then 6x is equals to 120 or x is equal to 20. Then we can get the coordinate is 20 and 30. On shop 2, manufacturer of bike B are 3 hours and bike C are 10 hours and the maximum hour are 180. We have the constraint 3x plus 10y less than or equal to 180. If x is 0, then 10y is equals to 180 or y equals to 18. The same thing goes with y. If y is 0, then 3x is equals to 180 or x equals to 60. Then we can get the coordinate is 60 and 18. This is the graph of 20 and 30 point and 60 and 18 point. We can see there is a region that satisfies both lines in here. To find that, we should use elimination in here and substitution, so we can get 10 and 15 as the point. The next step is to substitute all points that appear in this region with the maximum profit, and the result is the manufacturer should produce 10 of bike B and 15 of bike C to get their maximum profit. 2. An Italian restaurant offers a choice of pasta or pizza meals. It costs $3 to make a pasta dish, which it sells for $13. The corresponding figures of pizza are $2 and $10, respectively. The maximum numbers of meals that can be cooked in a week is 1,000 and 200, and the restaurant has a weekly cost budget of $3,000. How many pasta and pizza dishes should be cooked each week to maximize profit? To answer this, we need to consider pasta as X and pizza as Y. It was given cost of pasta is $3 and pizza is $2 and the maximum budget for a week is $3,000. Automatically, we have the constraint is 3x plus 2y less than or equals to $3,000. If x is 0, then 2y is equals with 3,000 or y equals to 1,500. When y is 0, the x is equals to 3,000 or x equals to 1,000. So we can get the coordinate is 1,000 and 1,500. On the other side, maximum meals that can be cooked in a week is 1,200. So we need to find how many pasta and pizza are cooked in a week. In this case, we use a constraint x plus y is less than or equal to 1,200. If x is 0, then y is 1,200 and vice versa. And the coordinate is 1,200 and 1,200. This is the graph. As we can see, we need to find the other point that passing through the lines. To find that, we should use elimination and substitution. And the point is on 600 and 600. Last, substitute all points with the maximum profit, and we can get 600 pasta and 600 pizzas that should be cooked as the maximum profit. 3. A small manufacturer produces two kinds of goods, A and B, for which demand exceeds capacity. The production costs of each item of A and B are $6 and $3 respectively, and the corresponding selling price are $7 and $4. In addition, transport costs are 20 cents and 30 cents for each good of type A and B respectively. The condition of a bank loan limit the manufacturer to maximum weekly production cost of $2,700 and maximum weekly transport cost of $120. How should the manufacturer arrange production to maximize profit? First, we need to consider goods A as X and goods B as Y, and we have constraint X greater than or equals to 0 and Y greater than or equal to 0. The production cost of goods A was $6 and goods B is $3, and the maximum budget for a week is $2,700. We have the constraint is 6x plus 3y less than or equals to $2,700, or we can simplify it into 2x plus y less than or equals to 900. If x is 0, then y is equals to 900. When y is 0, 2x is equals to 900, or x equals to 450. So we can get the coordinate are 450 and 900. On the other side, transport cost for goods A is $0.2 and goods B is $0.3, when the maximum transport cost for a week is $120. Then we find the constraint is 0.2x plus 0.3y less than or equals to 120. If x is 0, then 0.3y is equals to 120, or y equals to 400. If y is 0, then 0.2x is equals to 120, or x equals to 600, and we get the coordinate are 600 and 400. This is the graph. As we can see, we need to find the other point that passing through the lines. To find that, we should use elimination and substitution, and the result is 375 and 150. Last, substitute all points to the profit constraint, and we got 375 of goods A and 150 of goods B to maximizing the profit. That's all of my presentation. Thank you for tuning in. Wassalamualaikum warahmatullahi wabarakatuh.